This is now the fourth video in the series for in-home iron removal for Oakland Township. We've already talked about in previous videos where the iron comes from, how the water is treated in the municipal well houses, and then how the iron falls out in the water mains and how we use hydrant flushing to remove that, and then also how you can address some issues in your home using some flushing techniques. So now let's go into the utility room in a house where there might be an iron filter or a sediment filter. You could have a softener and brine tank or hot water heater. So an oxidizing iron filter is particularly useful on non-chlorinated systems. An iron filter functions by changing free soluble iron into rust, which can then be filtered out of the water. There's two types. There's going to be a self-oxidizing filter, and then there's an oxidation followed by filtration step. The mechanism is similar for both of them. This just has a couple different pieces of equipment that are associated with those. Iron filters in general work with water systems with no disinfection and no polyphosphate. They can also work with those systems, but they're just not quite as effective. Here in this diagram, you can see that the soluble iron, which is in blue, gets hit by the oxidizer, and that oxidizer might be air or chlorine, could be ozone, could be potassium permanganate backwash. Potassium permanganate is a kind of a purple liquid that you might get that's used with your iron filter. Once that oxidizer hits soluble iron, it then causes it to rust and precipitate. It falls out so it can be filtered out in your iron filter, and then you get iron-free water out on the other side. The next step here is to look at a system that has residual chlorine. So due to the residual chlorine in the Oakland Township water systems, almost all that free soluble iron will already have been changed to rust by the time it reaches a resident's home. So soluble iron that is sequestered with polyphosphate will not be oxidized. So basically an iron filter in this system will act just the same as a sediment filter. So looking at this, we have the sequestered iron that has a little green circle around it. It gets hit by the oxidizer, and then some of it might be turned into rust. It's not very likely. Mostly all of the rust particles were already rust before it actually got to your iron filter. At that point, the rust does get filtered out, but the sequestered polyphosphate gets through. As long as the iron stays sequestered in polyphosphate, you shouldn't have any issues with it. Unfortunately, it doesn't stay sequestered, as we learned in earlier videos. So overall, these are not an entirely effective treatment for public water systems in Oakland Township. If you have a private well, this is a very good system. These are a very good system for removing iron in there. In our situation, we just don't have it's redundant having an oxidizing filter after a chlorinated water system. So again, it's not recommended for the Southwest water system, the Southeast water system, or Norwood Knolls. Sediment filters. There's two types here. The automatic backwashing filters, which are a little bit more expensive capital cost, and then there's the replaceable cartridges, which is a lower capital cost for those, but ongoing costs are a little bit higher associated with that. Both of them are good. So those are recommended for the three water systems that we were just talking about: Southwest, Southeast, and Norwood Knolls. An automatic backwashing filter looks very similar to what you might see for your water softener. It removes sediment such as rust and does not require frequent replacement of cartridges. Some filters have a media that can remove residual chlorine and some soluble materials, but the effectiveness of these medias may be reduced over time due to polyphosphate in the water. Sediment will continue to be removed, but some of the other things won't. They might have a mix of activated carbon, for example.